retransmit of the broadcast system because we had sound problems on the last one, and I'm going to demonstrate how to deal with the how broadcasting works. So let me get back to this first one. If only my computer will be helpful and responsive. Here we go. Okay. This week is on distributed processing in Prolog, but we're also going to look at a system that originally was within a process and was later expanded to be outside of it, and that's the broadcast system. Broadcast provides messaging and agent-oriented programming and pub/sub to Prolog. It's quite often useful to be able to imagine your program as a series of agents that do one little thing. And these agents can be wired in using library broadcast. Whoops. These agents can be wired together using library broadcast, and they are the way you do that is you start through Prolog. And by the way, this is material that was last changed in post 7.7.13, so you may need a very recent Prolog to do everything in this lecture, because this area is being actively worked on. So if I this is an auto-loading module. So all I need to do to wire into library broadcast, I'm going to have things that listen, and then I'm going to have things that talk. And when one of these talks, the others, then it's just kind of shouting into the void, and then the others hear it and respond appropriately. So I can make a listener. Let's listen for the message foo. Okay. Now, somewhere else in the program, I can just say broadcast foo X. Okay. So I can make a second listener. Let's also listen for foo and say, tell you what, the only real change is going to be that this is the second listener. And now let's try our broadcast again. And hey, they both heard, they both heard an unbound variable. Well, let's bind that. Okay. Now, well, what about that unbound variable? And sometimes you want to say, hey, does anybody know the answer to? So let's add another listener. This time for bar. And this listener, this handler predicate, is going to, listen. There we go. Great. Let's add another one. And this time I will do between 80 and 82. Now, this time, if I do a broadcast, well, of bar X, it just says true, because it's not going to bind X. But if I do broadcast request bar X, it's going to give me all the responses from both listeners. Well, that's pretty nifty, and you can see this making some sorts of programming simpler, to have this kind of pub-sub going on and this kind of agent-oriented programming. This might be good. This might be a good alternate way to make a GUI, for example, or some sorts of blackboard systems, as they're called in AI. And that's fine. But there's something even cooler that can happen, and I'm going to need a different terminal for that one. And here I have used library UDP broadcast, which extends the broadcast system to tie things together using UDP packets. So I have initialized the system, and typically this will be the address of your LAN segment with 255 in the end. And then this is the scope, which I just discovered is broken in the head and reported it, but is supposed to establish a sort of a space to shout into. You can see that I've then established some listens, and since I've called UDP broadcast, now if I can set the same initialize in, notice, a different instance of Swipple, and now here I have listens for BAS between 1 and 5, and I actually also put a listen in okay, and BAS. Well, that's very peculiar. Okay, I don't know what's going on there. I don't know where all this stuff is. I'm going to stop it and start it again because I'm not certain where I left myself. Okay, here's Swipple, and I'm going to go back. I'll establish a context. I will listen for BAS and respond with 1 through 5. Here, let me halt. and do the same thing, and then I will establish a context again, and hey, there's a bunch of responses that I didn't know about. Well, okay, I sort of actually knew they were going to happen, but where are those coming from? Well, it turns out Pomatia, my robot snail, is on this same LAN segment, and this is an SSH into Pomatia, and Pomatia will also respond to Baz, and so I am getting a response from there. So this is a pretty cool system. The way you get the broadcast request to go everywhere is you must send a term of the form UDP sub, and this first is the scope. Remember that we established our scope was foobar, and the second is our term that we want to match. So the scope establishes kind of a space in which to broadcast. Hang on, let me here. So this would be one scope, this would be another scope, and then the second establishes the message we want to use. Excuse me. And then the scope we're not getting is and then when you do this, then it goes out to everybody. Now, there's a bit of a subtlety to this. That list must have some, how do we know when the list is done? Because UDP, of course, is connectionless, and we won't have a, and we'll just see connections or we'll just see responses come back. There is a 250 millisecond wait, and it will collect all the responses that happened during that time. This is actually why I had to use a find all and not just hit semicolon. If I try it with just semicolons, and if I'm fast enough, yeah, but that's about the limit of my reaction time. I run into the problem of I run out. Now, if you need to change that time, for example, you might be asking on a long process, you can actually change that time by transmitting a UDP/3, an Arity 3 version, and including the timeout. And now I've got more time to do this. Okay. All right. However, the downside of this is that means in your code this thing blocks for whatever that timeout is. So be aware of that when running, and using broadcast request over UDP is not probably, is in many cases not what you want. The broadcast over UDP system is best with broadcast with the async. So this is kind of cool, and I must say, for 4 years I programmed in an agent-based language where this was my primary means of communicating between encapsulated objects, and this is a beautiful way to work. It's incredible for keeping parts disconnected. And in fact, Pomatia is wired together this way. All of the parts are wired together by UDP broadcast. Okay, that's broadcast. That's about what there is to it. It's not that complicated. I'll see you in class, and on the Moodle and in the Slack.